So the next thing that we did was uniform circular motion. What we did is we had a 0.005 kilogram marble go down a long ramp, which is 1.02 meters, into a Hot Wheels loop, and it does a loop-de-loop, and the radius of that loop-de-loop is 0.09 meters. And so that's for our uniform circular motion. And so what we did is we took data on the how fast the marble is going into the loop. And so what we did is we calculated, we just timed how long it takes the marble to go down the ramp to the very bottom of the loop. And then so we averaged the time, we calculated the velocity of how fast it was going, and we plugged that into the centripetal acceleration formula. And so we got the centripetal acceleration, and then we plugged that, we wanted to find the value of the centripetal force providing the marble's acceleration at the bottom of the loop. And so we took the centripetal force equals mass times velocity squared over the radius, and we got 0.273 newtons. And so what we do with that is we take that and we plug it in to find the marble's weight at the bottom of the loop. And so that's how much the marble actually feels when it's at the bottom of the loop, so that's F of n. And so we take the summation of the forces, centripetal force, at the bottom of the loop we just calculated, 0.273 newtons equals the force of n plus the force of gravity, and the force of gravity in this case is the, it's negative 0.05 newtons, because that's how much the marble weighs, and then we calculate, or convert it to newtons. And so if you calculate that, the force of n equals 0.3231 newtons. And so the marble feels heavier than it actually, a lot heavier than it actually is at the bottom of the loop. And so you can see that in the force diagram right there. So the force of n is how much it weighs, so it's 0.3231 newtons. And the marble actually weighs 0.005 newtons, so it's a big difference in how it feels. And so next what we do is we wanted to calculate the actual time it takes for the marble to get through the individual loop. And so we can calculate the velocity from there and check our error in between the two velocities that we calculated. So this would be like the actual velocity. So the actual velocity we got was 2.547 meters per second, and that's based off the data that we got right there. And so we did an error calculation, so they weren't that different, 14.7% different, and that's just human error. That's a very small error, and it's just because of just timing. You know, it's very hard to get that exact time. And so they're not that different, so I think we did pretty good.